Alright guys, so today we're going to be talking about some things you're probably familiar with from Algebra 1 or even middle school. The distance, midpoint formulas, and then how to find area and perimeter. And we'll probably do a different video for perpendicular bisectors. So first, let's review what the distance formula is. The distance formula is just a formula that tells us the distance between 2 points. So here's the actual formula. D, which is the distance between the points, is going to equal the square root of x1 minus x2, which is really just the difference between the x coordinates, and then you add the difference between the y coordinates, and you square both of them. Okay, now this is real similar to the Pythagorean theorem, but when we're just given the 2 points, we'll use this formula. If we have a graph where we can count and make a triangle, then we'll use Pythagorean theorem that you guys probably remember from middle school also. And that theorem is a squared plus b squared equals c squared. So we can use either one of these to find the distance of a line on the graph. Midpoint formula is a little bit simpler. You're going to add the x coordinates and divide by 2. And you add the y coordinates and divide by 2. So really what the midpoint formula tells you is the point that's in the middle of 2 points. Okay, so you're just finding the point that's right in the very middle of 2 points. So this formula will tell us the point that's in the middle. Whenever we got one point x1 and y1 and another point x2 and y2. We just plug them into that and it'll give us the point in the middle. Alright, so let's practice this a little bit. So let's find the distance between these 2 points first. So we're going to use the distance formula, which is the square root of x1 minus x2 squared plus y1 minus y2 squared. Alright, so there's our formula. Let's plug in. So let's say this is x1, this is y1, this is x2, this is y2. Okay, so the distance is going to be the square root of x1 minus x2. So let's first do that. Minus 1 minus, and x2 is 6. So negative 1 minus 6 squared plus, and we're just going to replace the y coordinates. Now y1 is 5 minus y2, which is 6. Close your parentheses and square it. Okay, so all we did was take these four numbers and put them in place of x1, x2, y1, and y2. Now you've got to simplify. So first we've got negative 1 minus 6 is negative 7. And then 5 minus 6 is negative 1. Alright, so now we can square each of those. Well, negative 7 squared. Remember, square means multiply by itself. Negative 7 times negative 7 is positive 49, because a negative times a negative is a positive. And then negative 1 times negative 1 is positive 1. So the distance between these two is 49 plus 1, 50. The square root of 50. Now we can figure that out as a decimal by just typing it in our calculator. And whenever you do, you should get 7.07 if we round it to the hundredths. Okay, 7.07 if you round it to the hundredths place. So this is the distance between those 2 points written as a decimal. Alright, let's find the midpoint between the 2 points real quick. So the point that's right in the middle of them. So again, we're going to use the midpoint formula, which just says take the x coordinates and add them. And then take the y coordinates and add them. And divide them both by 2. And that will give you the coordinates of the midpoint. Alright, so let's add the x's. Negative 1 and 6 over 2, and then 5 and 6 over 2. So negative 1 plus 6 is 5 over 2. 5 plus 6 is 11 over 2. Alright, so this is the midpoint. This right between those 2 points, right in the very middle. You can make them decimals if you want, but I'm just going to leave them as fractions. Alright, so you guys go ahead and do the U-try down here. Try to find the distance between these two and the midpoint between these two, and then I'll go over it. So go ahead and pause the video, give them a try. So the distance between 3, negative 2, and negative 4, 5, we're going to plug in right here. X minus the x, so 3 minus negative 4, make sure you do minus a negative squared, and then subtract the y's. Negative 2 minus 5, negative 2 minus 5 squared. 3 minus a negative gives us a positive 7. And then negative 2 minus 5 gives us a negative 7. So we've got 7 squared plus negative 7 squared. We square 7, get 49. You square negative 7 and get 49. 49 plus 49 is 98. You take the square root of 98 and you should get 9.90 whenever you round it to the hundredths place, which is the second decimal place. All right, the midpoint, now we're not going to subtract the x's and y's, we're going to add them and just divide by 2. So I add 3 and negative 4 and get negative 1 over 2, add negative 2 plus 5 and get 3 over 2. All right, so that's the midpoint, the point right in the middle of those 2 points. All right, let's move on now and use these formulas to actually answer a problem. Now in this one, we don't really have to do the formulas because of the way the problem's set up. So let's ask, what is the length of AB? So the length of AB is the distance from this point A to this point right here, B. Okay, well, whenever it's set up like this to where they're on the same line on our graph, we can just count the boxes. So we can say, okay, that's 1, 2, 3, 4. Okay, so the length of AB is 4, which is really simple. And then it asks us to find the perimeter of the figure. So perimeter, remember, perimeter is the distance around. So you have to add up how far it is around. So we need to count the other sides. So this side is 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. So they're all 4. So we're going to add up 4 times. And when you add 4 4s, you should get 16. So that's the perimeter around this figure is 16. Okay, then the last part says to find the area. All right, so area, there's a formula for area. It's length times width. That's an L, that's a W. Area is length times width. So what's the length of the square? Well, the length is 4. What's the width? 4. So area is just going to be 4 times 4, which is also 16. So in this situation, the perimeter and area are the same. That's not always going to happen. Okay, just be aware that's not necessarily always going to happen. Could, but it's not normal to. All right, so you guys go ahead and do the next one. I'm going to pause the video, give it a try, and we'll go over it. All right, so pretty simple right here. The length of CB, 1, 2, 3, 4. All right, and then it asks you to find the perimeter. So we got to count them all. This side is 5. This one's 4. This side is 4, and this one is 5. So we had 2 4s and 2 5s and get 18. And then to find the area, you do the length 5 times the width 4. And of course, 5 times 4 is 20. So the area is length times width, which is 20. Okay, now let's look at one that's not so easy. So on this one, we're not given the square, we're just given a point, so we need to graph them first to determine where our square is going to be at. So we've got 0, 4, 2, 1, we go over 2, up 1, negative 1, negative 1, so we go left 1 and down 1, and then negative 3, positive 2, right there. So you can see that if we connect these, do my best to connect them, make straight lines, you can see that this forms a square. So the difference on these is the lines are at an angle. They're not going right along the grid lines on our graph. So we can't just count how many boxes over it is. They got to lie right on that line to do that. But right here they're going diagonally. So we're not able to figure out the length of this just by counting. What we got to do is use our distance formula. Or on a graph you can use the Pythagorean theorem. So what you can do instead of using distance formula is if I want to find the length, let's say I want to find the length of this line right here. Well, I can make this into a triangle. Okay, and I can count the distance on this leg. That's 1, 2. Distance on this leg is 1, 2, 3. All right, so now when you've got, this is a right angle, right? Whenever you've got a right triangle, you can use Pythagorean theorem to find a missing side. Remember that the side across from 90 is your hypotenuse. That's your C. It's always going to be C, the one across from 90. So in Pythagorean theorem formula, right, we've got a squared plus b squared equals c squared. So we're trying to find c. So we're going to plug in 2 and 3 for a and b. So we got 2 squared plus 3 squared equals c squared. 2 squared is 4. 3 squared is 9. That's 13. And we take the square root in order to get c by itself, because we don't want c squared, we don't know what is c. All right, so when you do the square root of 13, you should get 3.61 when we round to the hundredths. All right, so the distance of this line right here from point A down to point B is 3.61. And they told us it's a square. So if it's a square, that means all the other sides are the same. 3.61, 3.61, 3.61. So when we want to find the perimeter, we're just going to add up 3.61 4 times. Or you could do 3.61 times 4. Either way is fine. And whenever we do that, we get 14.44. So the perimeter is 14.44. Alright, then we also want to find the area. So to find the area, you do length times width. Right? Area is length times width. So what's the length? It's 3.61. The width is 3.61. So you multiply 3.61 times 3.61, and you get 13.03. So that's the area of this square that is connected when you connect all four of those points. All right, last thing, let's find the midpoint. I want to find the midpoint of AB. So this point is A, this point is B. So we're using these coordinates in our midpoint formula. We're going to add the x's, so we're going to add 0 and 2. And divide by 2. And then we're going to also add the y coordinates, 4 and 1. So 4 plus 1 divided by 2. And that will give us the coordinates of our midpoint. 0 plus 2 is 2 over 2. 4 plus 1 is 5 over 2. And of course 2 over 2 can simplify to 1. 5 over 2, we'll just leave it as a fraction, or you could write it as a decimal, 2.5. So there's our midpoint. All right, we've got the perimeter of the square, got the midpoint, and then we got the area over here of the square. Okay, so I'm going to pause it, let you guys try this. First, let's look at the perimeter. What we need to do is figure out the distance from one of these points. So we graph our points, and we see that the lines on the square are all an angle, so we can't just count to see how long they are. We need to use the distance formula, Pythagorean theorem. Either one's fine. So right here, we count out 3 and down 3 to go from A to B. So we make that into a right triangle right here, and then we can use Pythagorean theorem. Remember, the line we're trying to find is always going to be C. It's always our hypotenuse. It's always across from that 90-degree angle right there. So we can always make it C. So we put 3 and 3 in for A and B. 3 squared plus 3 squared equals C squared. 3 squared is 9. So we got 9 plus 9 is 18. Then you got to do the square root to cancel the squared, and the square root of 18 is 4.24. So the length of each of these sides is going to be 4.24. So we add 4.24 to itself 4 times and get 16.96 for the perimeter. And to find the area, we do length times width. The length is 4.24, so is the width. So length times width is 4.24 times itself, and that's 17.98 for the area. All right, then to find the midpoint of CD. So we're using the coordinates on C and D to find the midpoint. So we add the x's. The x coordinate for C is 1. The x coordinate for D is negative 2. 1 plus negative 2 divided by 2 is negative 1/2. And then we add the y coordinates. For C it's negative 4, and for D it's negative 1. So negative 4 plus negative 1 is 2. Or sorry, divided by 2 is negative 5 over 2. So there's the midpoint. And you can see when we graph this, if we graph negative 1/2, negative 5/2, we go left a half and then down 2.5. And we put our point right there. You can see it looks like it's right in the middle of that line, which it should be. All right, let's do one more. So this shape's going to be a little different. Let's graph our points. We got negative 3, 4, which is right up here. Now we got positive 1, 4. Then we got negative 3, negative 1, and positive 4, negative 1. So notice this shape is not a square or rectangle. It's what we call a trapezoid, and we'll talk more about this shape later. So first, let's find the perimeter. So to find the perimeter, you got to find the distance around it. Well, some of these sides are on the grid line, so we can count 1, 2, 3, 4. This one's 1, 2, 3, 4, 5. And over here we got 1, 2, 3, 4, 5, 6, 7. All we need to find is this one. It's not on the grid line, so we're going to have to use distance formula right here or Pythagorean theorem. So I always like Pythagorean theorem just because you've gotten used to using it. So let's make this a triangle right here. And we count out 1, 2, 3. And then down's 1, 2, 3, 4, 5. So to find the perimeter, we got to use Pythagorean theorem right here to find that fourth side. So we do 3 squared plus 5 squared equals C squared. 3 squared is 9. 5 squared is 25. 9 plus 25 is 34. And then take the square root of 34. And whenever you do the square root of 34, you should get 5.83. So C right here equals 5.83. That's the distance of this side, 5.83. So now when we find the perimeter, we're going to add up these four sides, 4, 5, 7, and 5.3. So whenever you add all those up, you should get 21.83. So our perimeter is 21.83. Now to find the area, okay, this is a little trickier. What you've got to do is divide the blue shape into two pieces. So we can go down this line right here and divide it into a rectangle and a triangle. Now the rectangle we can find the area of. We know that the area of a rectangle equals length times width. So we just take the length of that rectangle, which is 5, and the width, which we can see up here is 4, multiply those. So 5 times 4 is going to equal 20. So that's one part. Now we've got to find the area of the triangle that's left over. You might remember the formula for the area of a triangle is 1/2 times the base of the triangle times the height of the triangle. So what is the base of our triangle? The base is this line down here. It's 1, 2, 3. So the base is going to be 3, and the height is going to be 1, 2, 3, 4, 5. So we multiply those together. 1/2 times 3 times 5. You can do it on your calculator. And whenever you do that, you should get 7.5. So now we're going to add these two together. We got the area of the rectangle, the area of this triangle. Add them together, and we get 27.5 for the area of the entire shape. All right. So I'm going to go ahead and pause it. You guys try the last one. All right. So right here we've got to graph these 4 points. We get this green figure right here, which is another trapezoid. And we want to find the perimeter and the area. Again, perimeter is the distance around, so we count this side, it's 4, that side we can count as 2, and this side we can count all the way across and see that it's 7. It's this side right here that's going diagonally that we've got to figure out. So we can use Pythagorean theorem, making a triangle out of it, and seeing how long those two legs are. One leg is 3, one leg is 2, so we plug those in for A and B into the Pythagorean theorem. So we got 3 squared plus 2 squared equals C squared. 3 squared is 9, 2 squared is 4, add them up to get 13, and do the square root to get rid of your squared. When you do the square root of 13, you get 3.61. So the length of this diagonal side is 3.61. Now we can add up all 4 sides, so we add up 4, 2, 7, 3.61, and get 16.61 for the perimeter of the figure. All right, to find the area, again we got to split it into 2 pieces, so the blue line splits it into this rectangle over here and this triangle. And we find the area of each piece. So the area of a rectangle is length times width. The length of this rectangle is 4, and the width is 2. So we do 4 times 2 to get the area of the rectangle, which is 8. And then to find the area of the triangle, we do 1/2 base times height. So we do 1/2 the base, which is 1, 2, 3, times the height, which is 2. 1/2 times 3 times 2. When you multiply those together, you should get 3 for the area of the triangle. And so then you add the 2 pieces together to get the area of the whole figure, which is 11. I appreciate you all watching. Have a good time practicing. Love y'all.